So today we're going to be taking a look at how much it takes to pay off a car. So this first car we're looking at is $1.4 million, and just take an estimate. If it's 5% interest, how much you could make to pay it off. So we could do this. We could look at it as a recursive formula, and I'm going to try this on here. I don't have the writing tool available, so hopefully this will work. So if we were to look at this, our first, and again, I already messed up. So our first term is $1.4 million. And then our second term would be, we take our previous term, and so this should be A sub n equals A sub n minus 1. And if you remember, we have to calculate our interest. So if you remember from last semester, 1 plus, we take our interest divided by 12, because that's our annual interest rate, and then I'm going to subtract the $500. So this is our equation here for what it would look like. Now we can use Google Sheets to help us out with this. So if we go to Google Sheets, so we have 1400, $1.4 million. So this equals our first, the one above there, times 1 plus 0.05 divided by 12 minus $500. And if we do that, notice that it goes up. Because our interest, we're paying so much in interest, $500 payment doesn't make it go down. So I'm going to mess around with this. What about $600? Nope. What about $1,000? Nope. And we could mess around with this. And I did this earlier, and I looked, and $6,000 it starts going down. And remember, we can do this drop down bit, and we can start going down and seeing how many months does it take to pay off this car. So what we're going to look to do is look at your dream car. So for example, maybe you find a car and it's $37,000. We're going to look up these different interest payments, and we'll use a spreadsheet to calculate it out. So remember our recursive equation. So our first term is always the cost of the loan. And then in our recursive, to get our next payment equals, so it's always going to be, I put in the wrong subscript there, our previous times 1 plus the interest divided by 12. So it's our interest rate divided by 12 minus our payment. And then again, we can transfer that into our loans. We'll use a spreadsheet to figure out, by let's say your cost of your car was $27,000. So this equals A1 times 1 plus, let's say we have 5% interest divided by 12 minus $350. And when doing this, this has to be B1. I was like, whoa, that seems a lot. There we go. By doing this, remember, if it doesn't go down, change your payment to a little bit more. So the last one we're going to look at is a bowl of soup is 101 degrees Fahrenheit. Zaid measured the soup temperature each minute for 5 minutes and came up with this recursive sequence. So if we look at that, is it arithmetic or geometric? Well, we're multiplying and adding, so it's neither. So this is really called a shifted geometric. And then how long is it after 9 minutes? So we can go to our spreadsheet and say it's 101, so equals A1 times 0.8 minus, and it was cooling down at, or it was going up at 15. And again, I did A1. I keep needing a reference, so this is D1. So then it's 95 degrees. And if I drag down after 9 minutes, 79 degrees. And let's see what happens if I keep dragging. So it keeps going down. And if I drag a really long time, you'll notice I'm not getting lower than 75 degrees. So this is saying in the long run, the soup maintains about 75 degrees. And what that is there's an asymptote there at 75 that it will never go below that. So that is when you keep hitting enter, that is what's called our long run, because that 80% plus 15, those are about the same.